Sakti, the Radbury ethanol plant facing certain problems in such a way, the wastewater which could not be purified in such a faster way, or the where they've been using the old way of actually storing it in a separation area. We call it as a well. So this is right now we are talking about the wastewater. This is the wastewater
This from the production.
from the production direct. This is the wastewater, and you want to explain of how the process to develop the water into A and B.
Let's start from the ethanol plant first. The ethanol plant, they produce alcohol from molasses. They dilute molasses and then they put yeast into it to have fermented until there is no more sugar left. There is no more sugar left, and all yeast die. And they take only the clear part to go into the distillation tower. So we can see the distillation plant there.
So basically, this is only the dye.
And this is the what we call all the waste from there, which contain all the dead yeast and all the waste from the sugar plant. Because molasses actually is a waste from sugar plant, but there are residual sugar which is not economical anymore to produce sugar, but those sugar can be digested by yeast and produce alcohol, and that's why that is the standard process, ethanol plant or ethyl alcohol plant. And in this case, after they get this, now the way they are doing this is first they will give away partly to farmers, but since farmers can consume very little, they leave a lot of wastewater, and wastewater, once you leave it in the air, there are many bacteria that consume all this. There's a lot of nutrients here, so it can produce a lot of odor. That's why it is a very, very strong odor and give problems to the community. Yeah, and and now at the back you can see there is an oxygen tank where they are used to produce ozone. And the way they use it is that they used to blow ozone to blanket over the pond so that the smell cannot get through the ozone blanket. But since when it is in open air, so once there is a big wind blow by, then it will be blown away. we use Hilon process in such a way that we use electric field to actually we are producing inside electrolysis that we give out nascent oxygen to oxidize all those dissolved solids. And once, because if you pass something like this, even we dilute it, if we pass through carbon filter, it will come out as is, because all those we want to eliminate are dissolved in the water, so it's still there. So you are not solving problem.
Can you tell me that what the details of this waste?
The dissolved solid here are a lot in such a way that a standard TDS meter cannot measure. It's more than 10,000. Yeah. But the reason that we are diluted, the reason is because the higher the TDS, the better the conductivity. So when it goes into the machine, it will consume a lot of current. So we would like to control the amount of the current that passes to the unit. That's why today we dilute it to just 250. So you can see that we can control the current only less than 20 ampere. But if we leave 1000 in there, we get 100 over amp. So this is the reason why, and because the water, as we have shown here, that the water that we are going to dilute it, we get it back, and then we can use that to recycle in the process.
As I understand that Hitlon, they have certain ampere that they can go. What is the cutoff point for Hitlon? At which amperes?
It is like this, that in a standard cable, when you go up to already something like 16 square meters, and 16 square meters has a limit of 100 amp. So that's why we try to confine the unit to 100 amps. But it's 400 amp per phase. If it is connected in Y, the capacity for heating is already 66 kilowatt. But if we connect into delta, the capacity is already over 130 kilowatt. So from the capacity of the unit here with the line we have, we get already a lot very big capacity. Yeah, but for the process like this, most of the energy we depart through the water is producing heat. But in our case, we are not using heat to make precipitation, and that's why we would like to control the current just enough for it to precipitate, and we don't need extra heat. Yeah, that's why today we get quite satisfactory separation result with only just 20 amp.
Right.
Yeah, just 20 amp today.
So when the running is consume about 20 amps
Yeah, today.
per hour.
Yeah. So it's consume very little water, and then we can produce a lot of waste. Thanks to the technology, it makes the process very simple, in such a way that first, when you get the waste like this, you just dilute it to manageable TDS value, and which is we should keep it not more than 500 in real production. The reason for today 250 is that because we have very small filter. So if we put a lot of TDS in here, then we get a lot of solid.
Right. Where the filter cannot.
And filter cannot absorb it.
The best solution is to have additional filters.
Yes. We have a matching. We must have a matching. We have a matching capacity, and then the next stage for production is, first we must have automatic running. So this means that it will backwash automatically, and we have switching, so that we run this way, and then after this backwash we go to another unit. So the